Since 1983, Ford Australia has been involved in one of the most far-reaching changes the automotive industry has faced in Australia. And this is the result, the new EA Falcon. From concept to on the road, it's been part of a revolution in technology and in production techniques, and most importantly, it has benefited from a social revolution occurring within Ford Australia. This has been a total team effort from the beginning, involving all Ford employees and our suppliers. We've used a totally new approach to building vehicles. There have been many innovations with many old rules having been broken. Now Ford Australia is taking a lead and other car manufacturers are watching our progress. This is particularly so with automated robotic manufacture of body componentry. Nowhere has the ingenuity and teamwork proven itself more effective than on the door line here in the Broadmeadows Assembly Plant 2. With the support of the Australian robotics designer and manufacturer Machine Dynamics, we're proud of the developmental work we've done in this area.
The introduction of flexible manufacturing has driven Ford Australia to new and exciting frontiers in car manufacture. And nowhere are the results more impressive, more conclusive than on the newly commissioned door assembly line. From every perspective, the calculations have paid off. Tooling changeover from one door type to the next can be completed in minutes rather than hours and by one operator. The need for traditional rework and metal finish operations has been eliminated, allowing a more efficient use of labour. Utilisation rate of welding robots has been increased to around 80%. Safety and the employee work environment have been substantially improved. 24 robots and a number of other major equipment items operate in harmony, processing 6 different door types on the one line. Key features of the line are rotating tooling fixture cubes, gantry transfer robots for asynchronous transfer of door components from one station to the next, spot weld robots, an adhesive application robot, a programmable anti-intrusion beam conveyor, a 300-ton dual-action di-hydraulic press, and a DC poke weld robot. All controlled by a sophisticated Siemens supervisory PLC. The line is designed to manufacture a maximum of 120 doors per hour. That's about one door coming off the line every 30 seconds. Tooling changeover for each door type takes around 2 minutes to complete and can be handled by one operator at the push of a button. This contrasts to the manual line, which took at least 5 operators a complete shift for retooling. Now it's no longer necessary to manufacture more doors than are required daily with the resultant stockpiling. Production begins with the door inner and reinforcement components being manually loaded onto the rotating tooling fixture cubes at stations 1A and 1B. The cubes incline 45 degrees to present the door panel to the spot weld robot. After spot welding, the door is robotically transferred to stations 2, 3 and 4 for further spot welding operations. A unique feature of the line is the asynchronous transfer of door components. At station 5, the anti-intrusion beam is introduced. It's manually loaded onto an indexing conveyor and accurately positioned in the door panel by a purpose-designed gripper mechanism. It's then tacked in place by a spot weld robot. The assembly is then transferred to Station 6 for additional spot welding. At Station 7, a bead of structural adhesive is applied around the inner door perimeter. The volume of adhesive is proportionally controlled by a unique applicator nozzle, which ensures constant bead size relative to the robot tool tip speed. At Station 8A, the outer door skin is manually loaded onto a rotating fixture cube for spot welding of reinforcement components. Then it's robotically transferred to Station 8B. The inner door panel is inverted and married to the outer. Then the panel assembly is pre-clinched. An operator inspects the assembly at this stage to ensure that the pre-clinching operation is successful. The married panel assembly is then transferred to a 300-ton hydraulic press with a dual-action die. Once the press operation is complete, the door assembly transfers to Station 10 for DC poke welding along the clinched hem. From here, it moves to Stations 11 and 12 for further spot welding around the window areas. From Station 12, front door assemblies are automatically transferred to the indexing outfeed conveyor, skin side up, for final inspection. If the line is processing rear doors, the assembly is transferred to Station 13 for hydraulic piercing to allow for later addition of the moulding strip. The assemblies are inverted onto the indexing conveyor, skin side up, for inspection. The line operates under the control of a pre-programmed Siemens C-Matic 3200 IO PLC, which supervises the entire line, constantly monitoring every operation. The PLC has sophisticated text and graphics displays, which can instantly alert the operator to any problems which may arise. Safety and operational integrity are built into the line. Glass screens enclose the line, allowing operators to safely monitor every aspect of production. If an operator enters the area, the line immediately shuts down. To Ford Australia, the benefits of the new line are many. An overall improvement in production techniques. Heavy, repetitive work is reduced. Consistent production levels are maintained with a dramatic improvement in quality and finish. Consistent high-quality production eliminates the need for metal finish operations. Tooling changeover can be completed in minutes instead of hours. And a substantial improvement in the work environment for operators. Ford's commitment to flexible manufacturing has been made and is a proven success. For the door line, Ford Australia was recently awarded the prestigious Mike Munns Trophy for the most significant advancement in the science of materials handling by the National Materials Handling Institute. Since planning of the door line began in 1985, additional automated lines have been introduced. For the apron line, the hood line, and the deck lid line. And with the proven flexibility of these machine dynamics systems, Ford is looking ahead to developing similar technology for the Capri sports car, due for release in the United States in 1989. For the Capri, 2 new automated assembly lines will be commissioned during 1988. Ford Australia is setting the pace for the world's automotive industry. A new, consistent level of quality in manufacture. A clearer, cleaner workplace. More flexible manufacturing systems to meet the changing needs of a demanding marketplace. All designed to keep Ford Australia automatically out in front.